Welcome to the 7th lesson of our exponential function unit. We are solving equations today, exponential equations, by getting common bases. If two expressions have the same base and they're equal, they can only be equal if the exponents are equal to each other. For example, if we know that 2 to the x is equal to 2 to the 6, the bases are both 2, the only way that those would be equal to each other is if this x here is actually a 6. So that implies that x has to equal 6. We're going to use that premise here when we're solving these equations. All right, example, solve. Part A, we've got 2 to the exponent x plus 2, and that's equivalent to 2 to the exponent 8 take away x. So since the bases are already the same, the only way these two things can be equal is if their exponents equal each other. That means that x plus 2 would have to be equivalent to 8 take away x. From here, we're just going to solve that linear equation. Get x's on one side, get the number on the other, find what x is equal to. So I'm going to add x to both sides. That gives me 2x's on the left. So 2x plus 2 is equal to 8. Subtract 2 from both sides. That gives me 2x equals 6. And then divide both sides by 2. X is equal to 3. So as long as our exponent, the value of x is a 3, we're going to have the same left side equaling the right side. So I can always check that. If I put 3 in for x, that gives me 2 to the exponent of 3 plus 2, which is a 5. 2 to the exponent of 5 is 32. Over here, if I put a 3 in where the x is, I get 8 take away 3, which also is 2 to the exponent of 5. So that's a way to check to see if left side would equal the right side. All right, try the next one. See if you can figure out what x is equal to. Okay, you should have that 2x plus 5 is equal to 3x's. And then I'm going to get the x's on the same side. I'm going to subtract the 2x's from this side. And that's going to leave me with 5 equaling x. So x equals 5. And again, you could sub that in, check and see if the left side equals the right side. Now for part C, I don't have the same base. Here I have a 4, here I have a 1/16. So what I'm going to do is rewrite that so that I have that, the base is the same here. Now 16 I know is the same as 4 squared. So that could be written as 1 over 4 squared. And I'm just going to keep that as 4 to the exponent x plus 3. And that 1 over 4 squared could be written as 4 to the negative 2 using the reverse of the negative exponent rule. So now my bases are the same. So I can say the exponents have to equal each other. X plus 3 would have to equal negative 2. And when I solve that for x by subtracting 3 from both sides, I get x equals negative 5. All right, so part D, we're going to do the same thing. Now, I always try to take the bigger base, so the 16 in part C, I took that to be smaller, to be a 4 to the exponent of 2. Same with this, I'm going to take my bigger number, that 4, and I'm going to try and rewrite it as a base of 2 since that's my other base there. Okay, so 2 to the 3x would have to equal 1 over 2 squared, and 1 over 2 squared is the same thing as 2 to the negative 2. So I took the 4, changed it to 2 squared, and then applied that negative exponent rule to bring it up to the top. And that is all to the x minus 5. I'm going to apply the power of a power rule and multiply that negative 2 to both of these terms here. So 2 to the 3x is equal to 2 to the negative 2x plus 10. And then that means that 3x's would have to equal negative 2x plus 10. And then I would add 2x's to both sides and get 5x equals 10. Divide both sides by 2. I'm going to get x is equal to 2 for that question. All right, part E, I have my bases pretty well the same. It's just that this root, square root, I'm going to change to be an exponent. And from our rational exponent rule lesson, we should know that a square root is the same thing as an exponent 1/2. So that means that 5x take away 1 is going to equal 1/2. Then we're going to add 1 to both sides. So 5x would equal 1/2 plus 2 halves, which would be 3 halves, or 1.5. And then I'm going to divide both sides by 5. So 3 over 2 divided by 5 would be the same thing as timesing by 1/2. And that's oops, divide by 5. Divide by 5 would be the same thing as timesing by 1/5, not 1/2. I'm not sure where that came from. So that should be a 1/5. And then when I get, oh goodness, when I multiply those together, on the top I get a 3 and on the bottom I get 10. So my x is going to equal 3/10. And I'm having trouble writing that at the bottom of my screen here. Let's see if I can move that up a little bit. 3/10. There we are. All right, now again, I don't have the same base. I'm going to have to rewrite the 8 as a smaller base, but I don't, like 4 to the 1 is 4, 4 to the 2 is 16, so that doesn't really make sense. What I'm going to do is actually take both of those and make them smaller. So I know that 8 is the same thing as 2 cubed, so I'm going to change the 8 to be a 2 cubed, and then the 4 is the same thing as 2 squared. And then that's to the x take away 3. Okay, and you can go from there. Multiply that 3 through, and you should have a 6x plus 3. And that's going to equal 2 to the 2x minus 6. And the only way those equal each other is if the exponents equal each other. And then we get the x's on the same side, subtract 2 x's from both sides. I'm going to subtract 3 from both sides, and that gives me x equals -9/4. Okay, try the next ones. Okay, this is an exception to the rule. This is one where if I have a base of 1, I can rewrite that base of 1 as any base with an exponent of 0. So since my base here is 6, I could rewrite that as 6 to the exponent of 0, because anything to the exponent of 0 is equal to 1. That then means that 7x take away 3 is equal to 0. I can solve that then for x, and x is equal to 3/7. Now the last example that I have here, I don't have just a base of 2 to the x, I have this extra times by 3. So I'm going to undo that first by dividing both sides by 3. And that leaves me with my nice little 2 to the x. And then when I divide 96 by 3, I get 32. My bases are not the same, but I can rewrite 32 as 2 to the exponent of 5. And that leaves me with x equaling 5.